Let's say you give this diagram here showing a collision between two masses A and B, and the question says, two masses move towards each other on a frictionless surface. After they collide, mass B travels with velocity positive 2 meters per second. What is the final velocity of mass A? Also, calculate the change in momentum of A and B. To solve, we need conservation of momentum, which is given by this equation here, where P is the total momentum and the summation Px is the sum of all independent momenta. In our two mass case, the total momentum is going to be equal to PA plus PB, where these are the momentums of mass A and mass B. Note, they move on a frictionless surface. We can assume that no net external force acts on the object. So that means that the total momentum is conserved, which means the total momentum before is equal to the total momentum after. And we can apply this to our example. So this is our situation before. Both masses are traveling towards each other at a speed of 2 meters per second. And then this is our situation after they collide. The mass B travels to the right at 2 meters per second, and we need to find the velocity that mass A travels with. We apply our momentum equation here, noting that we need to find the velocity A after the collision. We can use the momentum after equation. We can start by knowing that the total momentum after is equal to the total momentum, since momentum is conserved. And momentum after is going to be equal to the momentum of the A mass after plus the momentum of the B mass after. And if we plug in our definition for momentum equal to mass times velocity, we get this expression. And if we look at this expression, we have two unknowns. We have the total momentum P, and we have the velocity A after. To find the answer, we need to find the total momentum first. Since we know both velocities before the collision, we can find it since we know that the total momentum before is equal to the total momentum after. So if we use the total momentum before equation and we plug in our definition for momentum equal to mass times velocity, we get this expression here. We plug in our known values for the two masses in the before situation. And if we do that, we can compute the amplitudes in the units of the left and right term. And we can do a simple subtraction to find this. So this is the total momentum of the system. Note it's not zero despite the two masses having the same initial velocity. And this is because mass A is bigger. So we can apply this to our after equation, which if we remember, it's this up here. The total momentum before is equal to total momentum after is equal to the total momentum since it's conserved. So we can plug this value in with our other known values given in the diagram. So we know that VA is what we're solving for up here. And we know that the velocity after for B is equal to positive 2 meters per second. If we plug all these values into our expression, we can isolate for V after by first computing the term on the right and then bringing this term to the other side. And then we can do a simple subtraction, which we do that, we get this. And then we can isolate for V after by multiplying both sides by 1 over 0.5 kilograms. And if we do that, we can cancel out the kilograms and we can do a simple division and we get this answer here. So we find that the final velocity is equal to negative 0.4 meters per second. And the negative makes sense because this is a head-on collision. What about the change of momentums of the two masses? So for the change of momentum A, it's going to be equal to PA after minus PA before. You can also write it in this form here. And if we plug in the values we found in the question, we find that the change in momentum of mass A is negative 1.2 kilograms times meters per second. So it loses momentum. And this makes sense because the amplitude of its velocity, if we look at the before and after, it loses amplitude and is traveling in the opposite direction. But what about the change in momentum of B? By applying the same process, we find that it gains momentum. And this makes sense because the total momentum is conserved. So since A loses momentum, B must gain this same amount of momentum for the total momentum to be constant. And we see that if we add those two together, we get 0. So the total change of momentum is equal to 0, which makes sense.